for this problem, we are told that the cosine of some angle theta is equal to -5/13, where that angle is between pi and 3π/2. And we're asked to find the tangent of 2 times that angle. All right, so for a problem like this, we're going to start off by drawing a little picture for ourselves. So we're going to want to put this picture on the xy coordinate plane. We're told that theta is between pi and 3π/2. So pi radians would be right here, 3π/2 radians would be down here. So we're somewhere in this quadrant. So we're going to start by drawing a triangle in that quadrant. It's got to be a right triangle, and it's got to have x, the x-axis, as one of its sides. And so once we've drawn that triangle, let's label this angle as our reference angle theta. And we're told that cosine of theta is -5/13. So cosine, remember, is adjacent side over the hypotenuse. So that's going to be -5 here over 13. The hypotenuse is always positive when we're drawing these pictures. And we know that this is negative because it's going backwards from the x-axis. Now what we need to do is we need to find this side. Let's call it A. And we're going to use the Pythagorean Theorem to do that. So a squared plus b, -5, squared is equal to c, 13 squared. So a squared plus -5 squared is 25 equals -13 squared, which is 169. Let's subtract 25 from both sides. We get that this should be squared. A squared is equal to 144. And so A, if we take the square root of both sides, A is equal to ±12. Now, the reason that we drew this triangle on the coordinate plane in this quadrant is so that we could see whether we want -12 or +12. And here we're going down from we're below the x-axis, so this is going to be -12. All right, so now with this little picture, we can figure out sine, cosine, tangent, cotangent, secant, cosecant, whatever we want to from that little picture, because we've got this angle that we're looking for, and it's a right triangle, and we know all 3 sides. All we really need, though, is tangent. So the tangent of this angle theta is going to be the opposite side over the adjacent side. So -12 over -5. Those negatives will cancel. It's just going to be 12/5. So tangent of theta is 12/5. Now we're asked to find the tangent of 2 theta. So we need to use our double angle identity, which is that the tangent of 2 theta is equal to 2 times the tangent of theta divided by 1 minus tangent squared theta. And now we know tangent of theta, so let's plug that in. 2 times tangent of theta that we just found was 12/5 divided by 1 minus 12/5 squared. All right, so on top here, 2 times 12/5 is 24/5. On the bottom, we get 12/5 squared is 144/25. If we're going to subtract those, let's go ahead and make this 25/25. That's just 1, but with 25 as our denominator, minus 144/25. Okay, so 24 minus 144, or 25 minus 144 is 119. So we get negative 119/25. So we have 24/5 divided by negative 119/25. over 25. All right. Now, we don't like this complex fraction like that, where we have a fraction over a fraction. So let's rewrite this. Remember that dividing is the same as multiplying by the reciprocal. So we're going to take this, this denominator here and flip it over. So this is the same as 24/5 times the reciprocal of this, which would be negative 25 over 119. And so 5 goes into negative 25, negative 5 times 24 times negative 5 would be, let's see, 24 times 4 would be 96 plus another, that's going to be 120. So negative 120 over 119. And so that's going to be our final answer.